Hi and welcome back to the Mr. Talbot Maths video, and this week's video we are looking at this problem here, which is finding the area of these two blue triangles combined. They're inside a larger triangle and it's got a square included, and we've got these two segments or line segments, lengths on that hypotenuse that are 3 and 4 respectively. Okay, so if you want to have a go at this problem yourself, please pause the video now, otherwise I'm going to go through my solution. Okay, let's talk through it. So, first things first, I'll put my right angles on here, and I've also got this right angle here from the square. Now, if I call this angle here alpha, this angle, because 180 degrees in a triangle, take your 90, is going to be 90, take away alpha. This one would then be 180, take 90, take away alpha, take 90, would be alpha, and this one then again would be 90 minus alpha. Now that's important because that tells us that we've got two similar triangles. The next thing I'm going to do, I'm going to put a length on the square. Let's call it x. So that's the side length of my square. And I'm going to call the height of this uppermost triangle A, and then the width or the base of that bottom right triangle there B. Now, because these are similar triangles, I know I've got a scale factor, and that scale factor here is timesing by 4 over 3. So what that means is that A to x, I have to times by 4 over 3, so 4/3 of A is x, to get from this side to this side, corresponding sides, and to get from the corresponding base, x, or 4/3 of x, is equal to B. Now, if I combine those two statements, what I get, replace x with 4/3 A, 4/3 of 4/3 of A is equal to B, which tells us that 16 over 9A is equal to B. Now, I'm going to rewrite that B now as 16 over 9. over 9A. Okay, so from there, I have also got the x's in here. I need to work out the length that x is ideally, and the way that I would want to do that is just by writing it at the moment, at least in terms of A. So I'm going to replace the x with 4/3 of A. Now what I'm doing here is trying to eliminate my variables, so that I'm just left with one variable. So 4/3 of A everywhere. Now, at this point, I can use Pythagoras with either the whole triangle or either of these smaller ones. And just to make things a little bit easier, I'm going to go with this smaller one here. So I'm going to use Pythagoras, block that off here. So I'm going to do 16 over 9A squared plus 4 over 3A squared is equal to 4 squared. Okay, so we need to work that out, and 16 over 9 squared gives me 256 over 81a squared plus 16 over 9a squared is equal to 16. Now if I combine those, I'm going to end up with 400 over 81a squared is equal to 16. Divide both sides by this fraction now, 400 over 81, and I get 81 over 25. So that means that because obviously a is positive, a is equal to 9 over 5. Okay, so now what I want to do is I want to go through this and just replace all of my a's with 9 over 5. And so I am going to have to work out a few things here, although I could work it out in calculation, but I'm going to write all of these things down. Now 4/3 of a, first of all, is the easy one to work out. So that top bit there is 9 over 5. 4/3 of a, that's the side length of my square. So 4/3 of 9/5. Probably could have done that in my head, but it's going to automatically simplify it for me, which makes things a little bit easier. And never be afraid to use your calculator, because it will prevent you making any silly mistakes. So 12/5, and then I've got 16 over 9 times by 9 over 5, which will give me 16 over 5. Okay, now I can work out the area of these triangles separately. So this triangle here, get rid of some of this stuff in the way, is going to be a half times by 12/5 times by 9/5. Half times the base times by the height is going to give me an area of 54 over 25. And then the area of this blue triangle is a half times by 16 over 5, the base, times by the perpendicular height, which is 12 over 5, gives me an area there of 96 over 25. Now, if I combine these two areas, 54 over 25, add the 96 over 25, I'm going to end up with something quite nice, to be honest. I'm going to end up with 6 units. Okay? Let me know in the comments if you managed to do that, and if you had a different solution. I'm always interested to see the different ways that people approach the problems and solve them, because ultimately that's going to help myself, but also everybody else reading the comments with different tactics, different strategies to attempt to solve future problems. Okay, thank you for watching. I hope you had a happy Easter, and I will see you in the next video. Bye-bye. If you like this video, then there should be plenty more videos just up here. Hopefully it's here. That's where it should be, the one that you want to watch next. Okay, see you in the next one. Bye-bye.